Hey, I have this problem on the board here. Today I have a reciprocal problem. I have x plus 1 over x equals the square root of 2. And then we have x to the 97th plus 1 over x to the 97 equals something we need to find. Okay, so to start with, what I want to do is I want to take our equation here and just square it to see what we get. So if I square this out, just squaring both sides, I'm going to have x squared plus 1 over x squared plus 2 equals 2. And then I'll just subtract the 2 from both sides, and notice then we have x squared plus 1 over x squared equals 0. Good. So what I want to do, I want to actually find, when I do these, I want to find a solution either for x or for some power of x that I can use to plug into this equation here. So what I can do with this equation is multiply through by x squared to get x to the 4th plus 1 equals 0, but then that just means that x to the 4th equals -1. Okay, so that's going to be useful. I also want to save this result, x squared, and I actually want to get, I think I might need one more result. So what I'm going to do is I'm going to take this equation and multiply it by this equation. So if we multiply the squared equation times the degree 1 equation, we're going to get 0 on the right, because we're multiplying on the right side, 0 times square root of 2. But let's just distribute this out, and we'll have x cubed plus 1 over x cubed. And then we're going to do in the outside and inner term, we're going to have x plus 1 over x, this equals 0. But the cool thing we have here, these will always, when we multiply through, they always repeat. And so we know our value for this piece is square root of 2 from our original equation. So our value for the cube is going to be negative square root of 2. Okay, so now I need more space, so I'm just going to clean up a little bit. Okay, so next what I want to do is I want to take my results from the right and plug it into this equation. So what I'm going to do is I'm going to rewrite our x to the 97. I want to use this primarily the fourth root, not the fourth root, the fourth exponent. So we're going to rewrite this. I'm going to write x to the 97 as x to the 4th times, what is that? No. We're going to write it as x to the 4th times to the 24th, because that's going to be the same as 96, but we're going to have 1 left over, and we'll write the other piece of this the same way. X to the 4th, this 24 times 4 is 96, but we're going to have this 1 x left over. And then we know our value for x to the 4th is -1. So this is going to be -1, and this is going to be -1. But when we take -1 to an even exponent, 24, we just get 1. So this piece is 1, and therefore this piece is also 1. So essentially, once we write this, we have our x to the 1st here times 1 plus 1 over x to the 1st power just times 1, and this is going to simplify all the way down to x times 1 over x. But we know what that is, because that's just our problem from the beginning. That's just square root of 2. So the answer for x to the 97th plus 1 over x to the 97th is just going to be the initial value, square root of 2.